Alright, so hopefully the first thing you realize is that this is the Unit 2 practice test, not the Unit 3. It should be changed on your paper. I'm going to go through these questions. I might ask a couple of questions along the way, and then you will be on your merry way. Okay, so the first question, if P equals -5, -4, and P prime is the reflection of P over the line y equals 5, what are the coordinates of P prime? So I would make a note that P is the pre-image. Y equals 5 is the reflection line. And we do not have a rule for that, so my suggestion is you graph it. And then P prime is going to be the image. Alright, so what I would do is I would either sketch a graph, use graph paper, or use the whiteboard graphs that I've provided. You want to plot your original point, -5, -4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, and that's called P. It's located at -5, -4. Then you want to graph your reflection line. So my reflection line is y equals 5, which is a horizontal line. So 1, 2, 3, 4, 5. And you have a line. Okay, it's horizontal. I'd also put how far away y equals 5 is, or I would actually label the line y equals 5. And then what you need to do is you can either count the blocks, so from the reflection line down to your point, that distance is 9, which means you need to go 9 blocks above the line. So you can count the blocks above the line, or you could do, you start at -4, you're going up, so you're adding, and you're actually adding a total of 9 to get to the line, and then 9 to actually reflect it, so you're really adding 18. And you would do -4 plus 18 to get to 14. And then your x-coordinate is not changing because it's going straight up. So that means that P prime would be at -5, 14. Again, highly suggest you graph the picture. Okay? Alright, number 2, you're looking at the figure at the right. You're reflecting A over the line segment PQ to get B. Notice P is actually on the reflection line, as is Q. They're telling you the measure of angle BQA is 37 degrees. So from B to Q to A, that's this whole angle. And that's 37 degrees. Okay, and then they want to know the measure of angle BQP. So from B to Q to P. So that is only half of the angle because the reflection line splits the angle in half. So what you have to do is 37 divided by 2, and you get 18.5. So then the measure of angle BQP is 18.5 degrees. Okay. All right, moving on to a fan, similar to the one shown at the right. It has 8 congruent blades. They're equally spaced apart. If blade M is rotated counterclockwise to the position of blade P. So that means you're going to start at M and end at P. And you're going to go counterclockwise, which is this way. Okay, so that's a good setup to have. You also want to remember that counterclockwise means your answer is going to be positive. Clockwise, your answer would be negative. Okay? So your first step is to divide 360 by the number of blades. So there are 8 total blades. That gets you to 45. What that means is each rotation or turn would be 45 degrees. And we were doing 3 turns. So you would multiply 45 times 3 to get 135. So the angle of rotation, you would have to turn M 135 degrees to get to P if you went counterclockwise. All right, number 4, you're looking at the triangle PQR graphed at the right. We're focusing in on point Q. So if point Q is rotated counterclockwise 90 degrees about the origin, then translated using the rule xy to x plus 1, y minus 3. What are the coordinates of Q prime? So we have this nice triangle over here, but they are only concerned with Q and Q prime. So first identify where Q is. It's at 3, 0. And then they're telling us to, first step is to rotate just Q. We're not concerned about the other points. Q 90 degrees counterclockwise. Okay, so you would refer to your rotating rules. And you can see the rules are when you start at xy, you go to opposite of y, x. So if we start at 3, 0, we would be at, opposite of 0 is just 0, we'd be at 0, 3. So you want to plot that point, 0, 3. We're not going to call it anything because they want our n to be called Q prime. Okay? All right, and then you also now need to translate. You're translating that 0, 3. And they want us to do what? What do they want us to do? They want us to start at xy and then add 1 to the x and take away 3 from the y. So if we start at, remember you want to start at what you just rotated, 0, 3. So 0 plus 1 is 1, and 3 minus 3 is 0. So now Q prime would be at 1, 0. Right here. Okay, so the coordinates of that are 1, 0. So do not waste your time doing that whole triangle because they were only concerned with Q. Next one is one of my favorite questions. So when a figure is reflected over the line with the equation y equals negative 5/2 x minus 4 and then reflected over the line y equals 5/2 x minus 1, what transformation occurs? Use mathematics to justify your answer. We have a reflection, which is 1 over 1 line. We have a translation that it could be. It could be a rotation. It could be a vector. Or it could be a dilation. Okay? But we know that going over 2 lines, most commonly it's either going to be a translation, which means parallel lines, or a rotation, which means the intersecting lines. So you really need to make sure you compare their slopes. So the slope there is m equals negative 5/2, and the slope in your other line is m equals 5/2. So they are different slopes for different folks, different slopes, which means the lines are intersecting, which means it would be a rotation. Okay, so this could be a multiple choice question with all of these as an option. So it is a rotation. All right, number 6, you are going to apply the vector to A, B, C, D, and then you're going to reflect over the y-axis. So I would put a 1 over the vector, a 2 over the reflection, and they want to know what quadrants will contain vertices. All right, so our vector says to go left 3, so that's a -3, and we're going down 2, so a -2. So that is our vector. So let's apply that to each point. Down 2, 1, 2, 3. So you did just kind of have to estimate, totally fine. Down 2, 1, 2, 3. Okay, and then B would be going down 2, B right there, and C. Now I'm not labeling these yet because we want to, for some reason they want us to call our image A prime, C prime, D prime. Okay, so now we're going to take these points and reflect them over the x-axis. So this point would come, this was A. So A would come right around here, and D would come right around here to be D prime. This was B. B would be right here. It's on a vertice. Oh, I'm sorry, it's on axes. And then C would come up here. Now, I'm not connecting because we're only concerned with the vertices. Okay? And they want to know which quadrants will contain vertices, and the quadrants are labeled as 1, 1, 2, 1, 2, 3, and 1, 4. So we are concerned with the primed images, which in this case was the blue ones. So C and D prime are in quadrant 2, so they will definitely be in quadrant 2. A prime is in quadrant 3, and B prime is on an axis, so it's not in any quadrant. Okay? Alright, number 7, if a size change is applied to -10, 4, and you get -4, 1.6, and center at the origin, what's the value of K? Hopefully you remember that K is the magnitude of the dilation. Okay, and then it's calculated by doing the image over the pre-image. Okay, so you could take -4 and put it over -10 and simplify, which simplifies to 2/5. Or you could do 1.6 over 4, and that also simplifies to 2/5. So your K equals 2/5. Alright, number 8, a rectangle has the vertices of 610, 1210, 618, 1218, and undergoes a size transformation of 1/2. What's the perimeter of the image? Well, the relationship is your perimeter of the image is going to be half, since that was our size change, is 1/2. So perimeter image is 1/2 perimeter pre-image. Okay? So what we could do is we could find the perimeter of the pre-image. And this is one I would also graph. Let me go back to the graph. Let me clear what's on here. And I might not fit all of this on the graph, but we can use our best judgment. So from 6 to 10, so 1, 2, 3, 4, 5, 6, 6, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so I'm actually not going to use this graph because it won't fit on it. But we can sketch one because it's going to actually form a nice rectangle. Okay, so if you want to sketch, feel free to sketch a axes right here. Again, it's just a sketch, so it doesn't have to be anything perfect. Okay. Alright, and then we would know that the point 610 is over 6 up 10, so let's just say it's right there. 610. And then the point 1210 would be over a little bit more, but it would still form a nice line there. And then same with 618, it would be up here. 6 up to 18. And then 1218. Alright, and it would make a rectangle. So, no, I don't want the arrow one. Alright, connect. Alright, looks a little bit more like a square, but you know you can't judge it. So, you want to figure out the distance. So, the distance from 6 over to 12 is 6, and then 10 up to 18 is 8. So now you just want to find your perimeter. Perimeter formula is 2 times the length plus 2 times the width. So remember, this is my pre-image, so let's just use 6 as my length and 8 as my width. And I believe that perimeter is 28 units. Okay, so that's the pre-image. You want to label that pre-image perimeter. So all we have to do is take half of 28. So we have to apply the size change, and half of 28 is 14. So our perimeter of the image would be 14 units. Another one you might want to graph. Alright, number 9, what are the coordinates of the image 312 under a transformation? So that big T just means you're doing something to it. Transformation, so something's happening to the point. 3x and then y minus 4. So all you have to do is do 3 times 3 and 12 minus 4. And we get 9, 8. And there you go. That would be the coordinates of the image under that transformation. Alright, last page. Number 10, what's the x-coordinate of the image when the point is rotated 90 degrees clockwise and then translated 3 units to the right? Alright, so let's first take our point xy and apply the rules of 90 degrees clockwise. Again, these should be on your calendar. Alright, so if we start at 4, 5, we're going to end at 5, negative 4. Alright, and then we're going to translate 3 units to the left, but it's only concerned about our x-coordinate. Okay, so 3 units to the left means we're actually going to subtract, because moving to the left means you get smaller. So you just have to do 5 minus 3 and you get to 2. So the x-coordinate would be 2. Alright, number 11, label the points are equally spaced along the line. That's perpendicular to both line A and B. Which point? So that means you want a letter, not a number. Some of you guys on the quiz gave me numbers. I need a letter because it says which point describes the reflection of y over b and then over a. So I would put a 1 under b and a 2 under a, and we're going to start at y. So y over b would be 1, 2, 3. 3 jumps to the line, so 3 jumps over. 1, 2, 3. So now we're at S, and now we're going to take S over line A. 1 to the line, 1 over, we get to U. All right. Number 12, look at the figure below. What conclusions can be made about line M and segment TC? So all we know is that line M is intersecting segment TC. We don't know what type of angle it's intersecting at, but we do know it's splitting this side equal to that side. So all we know is line M, it's splitting something in half, so it's actually the bisector. Maybe not the perpendicular bisector, but it is a bisector of segment TC. So that's all you know. Okay? All right, if point AB is reflected over the x-axis, what are the coordinates of the image? Okay, so x-axis, x-coordinate stays the same, y becomes opposite. Okay? All right. Number 14, how does the mapping affect the image compared to the image? It should probably say affect the pre-image compared to the image. So if we start at xy and we apply this mapping of x opposite of y, that is just a reflection, because we're not adding or subtracting, we're not multiplying, it's just a reflection over the x-axis. So that's the rule. Hopefully you can recognize that. Then you want to think about all the properties that are staying the same. Okay? Going from xy to x plus 3y minus 2, that means we are shifted up 3, down 2. And this is a vector, so all the properties that go with vectors would apply to this. All right, you're multiplying your x by 2 and your y by 3. This is a size change. So all the properties that are affecting a size change will affect these points. And then part D, we have xy to 1/2 x and y plus 1. So because we're multiplying by 1/2, it's a size change, and then because we are, it's a size change of 0.5, and then we are shifting up 1 unit, so that means we also have a vector. So this would take all the properties of a size change and all the properties of a vector. All right, I hope this concludes your practice test. Hopefully you understand a lot. If you don't, please see me before or after school with questions, and we will be ready for the test.